control room and then doing the analysis of the data. So these keep happening. But nowadays, what we see, everything, uh, uh, everywhere we'll find the IoT. So IoT is itself is not an one technology, or it's a combination of multiple technology. So we will see in the going forward slide. And if I miss something, but I had given certain links where you can do with that, you will get a lot of material there. So let me start with this. So this is generic, very one of the definition for the IoT. So it is nothing but a network of physical objects. When we say object, it includes device, vehicle, building, and any item which we can connect, we can talk or connect, get the data or transfer the data. Maybe embedded with electronics, software, sensor, network. So any connecting any object and creating the network, so that's an IoT. Uh, we can use IoT in any field. Mm, we can't say it is only used in industrial. It's used in industrial, agricultural, medical, automotive. You name, everywhere we will find, because this is the concept. Like when we have to connect to device, take the data and do on that data, if we can do any kind of analytics. So that's all a piece of the IoT as a framework. So again, as I said, like when I started my career, we were calling machine to machine. So that is one of the definition. Cisco calls is Internet of Everything. So somebody says it's a world-size web. Now this IoT has come into limelight after sometime 2010, 2000, somewhere around that time. So before, it's not that before that devices were not connected. Now, if you see this graph on the right side, we'll see the red indicates number of people and the blue is the devices. So it is almost rather devices were lesser and the people were more. But after 2014 or 15 rather mainly, it has changed quite drastically, where we see number of devices has increased like anything, and people remains more or less same. That might have slight increase, but compared to the growth of the devices, it's very minimal. What it shows that even nowadays everybody has more than one mobile with them. Same way. Our vehicle, whatever car we'll use, the basic as well. So it has a connectivity to our mobile. Or nowadays, we see many product which provides a connectivity with mobile. So with that, not only our mobile, even the original manufacturer OEM also gets the data from their product. Uh, Kind of costlier like AC or fridge, something, or the washing machine. Depends. It depends. So all that is because of the cheap communication. The communication becomes much easier and much faster. So if we here I'm trying to explain you the landscape of IoT as a framework. Uh, Say capture, it has a major four thing: capture, store, analyze, and present. So when we say capture, we will collect the data. Data can be generated from the sensor. Data can be generated from the any other application, or or any device. Now, once the data is collected, that we will store that data. Again, we will see the what are the components involved. This is the kind of landscape, but we'll see in the next slide. So normally we will see in the next slide. So and the storage, when we talk, that is like storing into the physical disk, and then analyzing that data. So there are various tools, various framework is used. Once you have the data, and then once we have the analysis of the data, we'll put it into the various presentation. So there are various tools available for that. If it's a Kibana, Tableau, Power BI. These are the standard tools provide Power BI from Microsoft, something like that. Kibana is, I think, open source. So, so this is one landscape. Any question or shall I move? So,
Go ahead.
no, no, please go ahead. Ask if any question. Okay. Any question or shall I go
Yes.
ahead?
Questions. If you have any questions, just please raise your hand so we can unmute you. Technical team, please unmute all for 1 minute. So if anyone wants to ask, then they can ask in between.
Okay, sir. All are
Sure.
unmute.
Okay, yeah, all are unmute. Anyone wants to ask, have any question, they may ask now. Okay, sir, no question.
Okay. So, the slide which is I have shown here, uh, so you will find multiple, like even if we take any application, banking application or any application, all same application has undergone multiple changes. Now, so we as an developer architect know that there are various way we can design our application, or we can have multiple architecture or a framework. So and I myself worked with a couple of framework in eInfochip, one for automotive, sorry, and one for industrial and one for the medical. So uh, there are three-tier architecture, or there are microservice-based architecture. So this what I have presented the framework which is for the microservice-based. Now here, even on the edge or the gateway side as well, we have the microservice as a concept. So, so to talk slightly more about the microchip before we move ahead and try to understand this framework. So earlier, normally it's like a single application, one exe run that, and then application will do what needs to be done. But if it is waiting for, say, keyboard input, then it will not do anything else. So that will create a problem. So then there has come multiple things like the either thread or multiple process and all that. So now in that evolution, if we see, uh, we had a three-tier architecture where the top will be the visualization, the middle is a business logic, and the down or the third layer is a data storage. So even that is not scalable. And I can't say it's latest, but yeah, eventually there is another idea or architecture where we recreate multiple service, removing one service, adding new service. It becomes much easier, much flexible, and that's possible with a microservice based architecture. Now, what this describes, if we start from the bottom, so we have a device. When we call a device, it is a in the next slide we will talk various physical component. So the device is we can call the gateway. So sensor will be connected with gateway, and gateway will connect to the cloud, be it Azure cloud, be it a Google, Amazon cloud, or a Google cloud. So gateway, we will see the more detail about gateway as well in the few slides. And on top of that, so gateway, the device will have hardware and the operating system. And we have created this with the virtualization or the Dockerization. So that becomes like I can run it on a multiple hardware. So that's the main purpose of this one at an edge level or the gateway level. And communicating to the various cloud. There also we have the router or software distribution bus where it will I can convert that from AWS to Azure as well. And on top of that, we have various services. So like communicating with device, I will use either MQTT, AMQP, COAP, or HTTPS. So all that is a part of IT bus. That is one service, and it will talk to the cloud. Same way device with a device, it can talk over multiple protocol, Z-Wave, Modbus, Zigbee. So these all are the services running on my gateway. Business specs space where we have implemented rule engine, scheduler, and transposer application. So this is the what we saw. It was a microservice based framework. Now this is a typical or reference architecture. So any IoT platform, if we see in the physical way, if we start from the left, uh, we call IP enabled device that can directly talk to the cloud. That existing IoT device, they will have a agent. They can also talk to the cloud directly or via gateway. And low power device, they will uh, either via gateway. Always certain devices they will connect to gateway and they will talk. So you might have heard many IoT hobbyist has created a project in IoT using Raspberry Pi or something, and as simple as switching on and off light, fan using the or measuring the temperature using the Raspberry Pi. So all that sensors like switch or uh, any sensor get connected to the gateway, and then gateway has an agent or a library provided by the service providers. Say if it is Azure, then Azure SDK. If it is Microsoft, then sorry, Amazon, then it is a Greengrass. So each has a different service for the gateway, and there are each has a parallel or the similar service. If we see IoT or IoT event is for communicating between gateway to the cloud for Azure. The green grass is for Amazon. So like that parallel service both has for storing there is a something. So yeah, that you can find out. I have tried to give some certain things in the next slide. And once it is come to the cloud, so they call cloud gateway, but that's a service as I named IoT service or event service for Azure. And then it stores the data. There are various other service like there are data. If we talk about getting data, like say Hyundai has implemented IoT each car, so then every car is sending the data. So it's a huge number of data. So again, that to process certain so stream event, and there are various service each cloud service provider provides. So the middle part is for getting such a huge data, storing it into the database, and other side the analytics or machine learning can be applied or means that module will take the data and then do the machine learning or AI, predictive maintenance, predictive analysis, diagnostics. Lot many things can be done. We'll see that in the next slide as well. And the final part on the right side is a visualization. So we can create our own visualization or we can use the framework like Power BI and Tableau. That also provides a very nice visualization for the data. So this is a typical reference architecture for the IoT. And the previous what we saw, the microservice based, it is microservice based architecture, but it does the same thing. So as our topic is for edge computing and the data analytics, we'll talk slightly more before we go there. Is a both the things happens on the gateway. So what is gateway and what what is the importance of the gateway? Gateway is again like getting the data from the various sensors. So and it plays the kind of a heart of the IoT system. So what features should provided by the gateway? So these are some of the features which we have listed, and uh, e-info chip is a service company, so we don't build the product. But the link which I have said, if you see, we have built a complete gateway as a product, and we will our customer when we can use that as a uh, reference design and then fast go to market. So uh, okay, so that's it's about what we have designed. But if we talk, so first most important feature which gateway should provide interoperability, devices, operating system. Again, it should not be very. It should provide strong integration with through API. Uh, Either I can put it Azure SDK or any other cloud SDK should be able to easily work with that one. So all uh, that's the second one. Application lifecycle management, that also gateway should help, like one version of the gateway or one version works with something and other version works with application updated application. A simple example, our mobile. So something similar to that one. Security, so we which is very important aspect. Otherwise, people can hack the device, they can manipulate the data, and that can create disasters. So there are stories when the IoT came new in America or North America or any European countries, they had used the IoT system to control their ACs in home. So somebody hacked that device and then did the reverse way. If it is very cold, he will further increase the temperature instead of reducing. So it can create a trouble. So security is very important. Uh, Again, based on the need, it should have a capability fog or edge computing. So uh, edge computing, we'll see. I have complete slide for that, so we'll see in that detail. So what is edge computing? How what that feature helps. Again, offline continuity and shadow. So this is slightly similar to the edge computing, but say I have kept my device or the gateway at a remote place, and if there is a any discontinuity, there is no connectivity, then device or gateway should collect the data till the time it gets connectivity, and then when it gets connected and send all the data. So that is also one of the feature. High availability, because this is the, as I said, it's a hard. If gateway is gone, then your system is not going to show anything. So it's very important that it should be available almost 24/7 for any of the IoT system or platform, and it should be scalable. So these are the typical core component. And if you see the link given there, you can see the gateway which is designed by InfoChip. It is for the industrial, which is ruggedized one, and uh, why I had given that link. So the certain things available are openly, so or say for everyone. So you can have a look at. Any question? So if you have question, you can raise so the moderator can intimate, and then I will stop and will allow you to ask the question.
Sure, sir. We will look after that. At this
Sure,
time, nobody has raised the hand,
sure,
so please continue.
sure. So again, I think if this speed we will go, we'll finish quite early. I'm not sure how we can see. Okay, how we can interact, and then if it is interactive, then it will help me uh, to or it will help all of us. Okay, so let's go ahead slightly more. Now, if we say data analytics, so normally you take any IoT platform, be it any domain or any area of application, uh, agriculture, automotive, or any. So what is that? So we do that. We talked about it. We do the data collection. Now, when we say data collection, so gateway, which is connected to sensor or any other device, which will take the data. If I will take an example, I said temperature, or if we take another example, normally most of the camera has a either Wi-Fi or Ethernet wired connectivity. So that itself acts as a device which is IP enabled, so it can directly talk to the cloud. Now, how does it talk? So then we have to add a component which I have not mentioned here, but it will be the next slide. But that's called we talked in the previous slide. It's a SDK, which is provided by the cloud service which you are using. So either it is Azure, Amazon, or uh, Google. Now, uh, device talks to camera is it's like it doesn't have any other things, but directly it takes the images and then it can send the photographs or the video over the MQTT or any of the protocol, and then uh, we can there are applications like nowadays there are cameras available in the market where you install it your home and anybody comes to your home, you will get alert on your mobile that somebody is there. So you can see the live video or photo depending on the subscription we have taken. So that is one example. Another is like uh, we connect devices, either temperature sensor, switches, or any device, or uh, which will be talking via wired, either via GPIO or through wireless or Bluetooth or any of the wired protocol. It can connect to the gateway. So gateway on one side should provide all that or should have all that capability so that it can connect to various device. So there are LoRaWAN, there are n number of things available, and that way we can connect various device with gateway. And same the SDK should, on the other side, connect with the cloud platform and send the data to the cloud, where majority MQTT or COAP or HTTPS protocol has been used. When we talk about the storage, once we have the data at the cloud side or the server side, we will store that data. There are various ways. I have used couple of database, either Apache Cassandra or MongoDB. Normally, Normally, if we take banking or any of the application, they use SQL, Oracle SQL or PL SQL, the structured query language. But here we don't know which device will send what type of data, so it's not structured, and that's why NoSQL database has been very widely used. So both the example are of NoSQL database. Again, third portion or third part in the analytics is a processing framework. So when we have the huge number of data, so then uh, it becomes more easier if we use any readily available framework which help us to streamline or real-time data and then processing that data. So there are also a couple of examples, that is both are open source, Apache Spark and Flink. And visualization, the fourth and final part of the data analytics, where we can visualize the data using Kibana, Tableau, or Power BI, or we can create our own dashboard using any of the web technologies. So the challenges on the analytics or the data side is scalability, interoperability, security, and energy consumption. When we talk say scalability, uh, Nowadays, most of the cloud platform provides that facility that we can runtime scale number of servers or the server in such a way that it can uh, uh, interact with various gateway or various devices. Same way, interoperability, that is still a challenge. If I have created my solution using Azure, I'm stuck to that. I may not be able to take as it is just like that and remove Azure and create it into Amazon or Google. So that is still issue. Security also more or less was a challenge, but now it's not that much. But when I store the data in the cloud, I do not know who has access, and that's why it is still unsecure, and somebody can steal my data. We have seen it recently there were a couple of data has been stolen or hacker has been hacked the data. uh, I'm not remembering, but that was like somebody's personal data, and they that has been hacked. So that security is more thing. See, energy consumption. If we talk data analytics on the device side, that is a concern because if you and that will come into the next part as well when we talk about the when I will talk about the edge computing. How analysis will help? There are various things. One is a descriptive analysis. Uh, if I have to say uh, one simple example for that descriptive analysis is let me take an example of a thermometer. When uh, when we read the data from thermometer every second and store it, so then we know that we have a data and we can analyze, we can plot that data. It will show, I can see the trend. Either temperature is remain constant, reducing or increasing. And same thing, same data when I visualize, I can use it to diagnostic investigation to investigation if something has happened. Now suppose this thermometer is placed into the CPU and then temperature is continuously increasing. So that will show, okay, something has happened, or we can see that. And after that, if CPU is gets turned off or has some problem, then that means there was a continuous temperature increase for whatever reason, and that it has stopped or switched off. Now, same thing, same data can be used, or data can be used as a predictive analytics. Uh, to extend the same example, like if we have created a system where we monitor and we know threshold, okay, that so CPU or the temperature in that area should not be going above certain degree, and if it goes, then we will initiate the or predict that this can happen, and then that alert can be given to the right team who can act on that one. So that is possible, and that's why early there are uh, many product manufacturer has given that capability. Uh, AC, mainly AC, we have seen that you might be remembering Amitabh Bachchan used to come in that ad. He will showcase he is switching on AC from the airport or somewhere else. He is not inside the house. Now that is possible because it is connected and then it is continuously sending the data. Same data, if there are critical parameter, if it is below or above the threshold limit, then AC directly can AC or the manufacturer can send the service engineer to our house. So that is what is possible with this one. And same predictive, and then that same thing can be used as prescriptive analytics. So I gave an example like so same data that prediction can be used by the OEM to suggest or take an action. Any question?
Hello, team. Please unmute all.
So this is very critical part. I have not talked much about the various stages or various component gateway on the cloud
Hello,
side, what
hello,
all is
sir.
there.
Sir.
Yes.
One of my question is, how can we use the IoT infrastructure in our education system? How to implement? What type of data we have taken from the real classroom or something like research work in this scenario?
Okay. Let me give you one simple example. I think this has been implemented somewhere. So I'm not sure about research, but say uh, one simple example is we there is a norm or practice that we take an attendance of the student, right? Now, if you I now majority of the classroom has a video camera as well. So you can just apply video analytics, face recognition that okay, 30 students are sitting, who is that? And then automatic attendance is being filled. So this is one example which is applicable, and this has a very good market use case as well. Let's say this is deployed, same solution is deployed in bus stop, railway station, or airport where there are a lot of people coming. Now, if there is a threat, okay, somebody or known human being say, okay, this is a threat, or we need to catch that person, whatever. So then that algorithm can catch. So this is one example of IoT. Are you agree?
Yes, sir. Thank you, sir.
Yes, sir.
So like that, yeah, it's like IoT, as I said, right? It is not new. It is old, but it has become very easy or more. Uh, we see more and more usage of that because of the uh, multiple things like storage is cheaper, the lot of data being getting generated, and lot of innovation also can happen because like everybody has a mobile. Through mobile also lot many things can be done because you create a mobile app and each mobile app keeps sending the data. Many things can be done. It's like once you define the problem and then solution becomes much easier. Many times it with IoT. Anybody, any other question?
Any question? No, sir, no one.
Okay. So moving to the next topic, edge computing. So we talked right in IoT, number of device will be, we don't know, millions of device with sending the data or gathering data and connected to IoT. Now, what happens if we keep sending all the data to the cloud server? So, and network has a limitation, so it will increase the latency. So, so that is one problem. And to resolve that, we do edge computing or called fog computing. So in that, we will process data near to the device and we'll send the data which is or sometimes the analytics we send it so it will be much lesser data. So that will improve the overall performance of the system. So I give an example, AWS providing Greengrass service, which is based on the edge computing. So something similarly available for Azure as well. Uh, let's take an example of the same camera. I We have deployed, say, if we take an example of Ahmedabad airport, so still it will have, I don't know, 100, 500,000 camera. And each camera started sending data of everybody will be, it's not difficult, but it will become difficult at a cloud side or the server side to do the analytics on that one. and it will be delayed. And if you want the real time, so it is better to uh, do the use case or the scenario based analytics on the device and the send the data when it finds something like say somebody is fallen down. So then it will immediately send some location. The camera itself is a one location. So and it sends then they know where what has happened. So like this is one example. If somebody is anything there are various use case can be implemented, but again so all data will not go to the cloud, but that will be happen on the device, and that device will send the alert. So alert will be much lesser, and that's what uh, is can be achieved using edge computing. uh, Again, this is just a block diagram. Uh, if you see on the bottom side, we have the various sensor which sending the data to the gateway at real-time data, and gateway is capable. So uh, Raspberry Pi, if we take an example as a gateway, so it may not be able to do the video analytics. So then we have to use something like NVIDIA Jetson or something like that. So it will increase the cost of your gateway. So we have to see the trademark uh, trade-off. We have to do the trade-off. That shall we do it at a cloud side or shall we do it at a device side? But what you see, so if we need to do that analytics at a device side, then we need to have a slightly higher configuration of the or we should have a better processor. Same way, we as an that gateway should cache certain data or store certain data for some time. So that will increase the memory footprint as well. And again, then communicate the what necessary to the cloud, and that is easier. Any question? So when we do a lot of data analytics on the device, the major challenge is to optimize or for low energy consumption, and that's ongoing challenge for hardware engineer as well as the software engineers, because many of the gateway runs on the battery, and then battery has to if it is gateway, like say if we take an example, the camera deployed at the traffic signal. Now, if that battery goes very frequently, then there is a problem. But many place power is there, so they're not an issue. But certain things, certain place, even power is not available. Purely depend on the battery. So that's energy consumption or low energy consumption devices or program it should be written in that way. I I think I'm near to my end of the slide. I just listed down. If you Google, you will get a lot many things. But here I try to focus more on the edge side. Uh, I will go back to one of my slide and we'll talk as well if required. So uh, platform, we know AWS, Greengrass, Azure IoT, or Google Edge IoT. For if you have to do AI or AI/ML on the edge, that also framework like Ajax, OpenVINO, and programming language, it is any, but majority Python, C++, Rust, sometimes Go, all that is been used. So current new or trend is a deployment of AI models at edge of real-time inference, 5G integration, blockchain, and autonomous system. So this is a Microsoft link, uh, which will give you slightly good details. Now, let me go back to. Okay, even we can talk on this slide. Now, if we as a if I okay, no, for you as a professor, if you have to see ki what where if you have to do something, how do we start? So this is not a single technology. Now, when we talk about device side, cloud side, and the visualization, so all three has a different languages, different kind of I would say tools, and then services used for that. So majority on the device side, embedded engineer with C++ knowledge, they can contribute and can do better. And they should know or they should know how to integrate various API or SDK. So in a way, if we have to use any of the cloud, so they provide their SDK and that we have to use. So that they provide it all. If you want C++, they will provide Java, they provide Python, they provide. So that is different. But device side, uh, good understanding or any electronics or a computer science engineer can work, but with a good and exposure to the system level programming. On the cloud side, again, good understanding of the various services provided by the cloud provider, and then using that and creating the APIs as simple as uh, to onboard the device, offboard device. This is one example. So that can be done in the any Java or C# as a language. And same way, uh, the storage. So they should be uh, they should know any of the NoSQL. Both Azure AWS provides that one, and we can store the data. And third portion is the visualization. So that is normally done in HTML, CSS, JavaScript, or AngularJS or React.js. So these are the three layer and the three mainly this technology. So this is not a one-person task. If one person does, then it is very primitive. But to develop the product, we need the expert in each area. So you will get a good reference or good material also here. And these are the use case like if you have to monitoring for monitoring solution, complete
Yes,
SDK is given by
one
sorry.
question. One minute, sir. We will unmute him. Yeah.
Dhiren bhai, can you unmute the Barot sir? He might be asking to ask.
Yes,
He's like to ask some
he is
question.
unmuted.
Yes, it is unmute now. Sir, hello.
Sir,
Yes, sir.
please be louder.
Sir, I want to ask that edge computing is mostly performed on gateway only, or there is like this two tasks should be separated on two separate machine like
Okay.
that.
So let's understand what is gateway. And so I give an example of a camera, right? So camera is a see gateway has a one thing it should have is a Wi-Fi or IP connectivity, wired connectivity, so that it can talk to the cloud. So camera has that. So camera also act as a gateway. Now, if we take any sensor, like say, I want to transfer the data uh, from certain device, but it doesn't have a IP or a Wi-Fi capability. Either they can talk on a Wi-Fi or any of the sorry on the Bluetooth or Zigbee kind of protocol, right? There are various sensors available. And nowadays there is a combo temperature, humidity, and all other things you can see. There are small device comes with that, but they talk over the Bluetooth. So now gateway will connect over Bluetooth to that device and get the details. So, so your question is like,
So, sir, what I want to ask is, gateway will be mostly capable of doing edge computing, or in some cases, this edge computing will be done on separate machine kind of
no,
thing.
no. So edge computing, when we'll say we would like to do at a device near to the device. So mostly it will be done on the gateway. Now, uh, the example which I gave, like Bluetooth device connecting to the gateway is one, and camera itself is a gateway. So on that also it can be done. So yes, to answer your question, it should be done in the gateway.
Okay. Thank you.
So I would like to share a video. I'm not sure how much it will helpful, but let me. Uh, uh, I am
Sir,
Sir, I think.
hello.
Okay.
sorry.
Sir, there is a one question. There is a word
Please.
about fog computing. So, what is the difference between edge computing and fog
No.
computing?
It's a similar synonym. So somebody is calling fog computing. It's normal. Cisco calls it fog computing. Otherwise, everybody calls it is edge computing because Cisco tries to be slightly different. So,
So, what is
but
the
no
main basic
difference.
difference between them?
No difference. It has similar names, synonyms.
Okay, sir. Thank you, sir.
Anyone else?
Sir, can you share the recent innovation projects that you are working on if it is permissible?
Yeah. I'm just showing that. Is my video visible?
Yes, sir. It's a visible.
Audio?
Hi, welcome all of
Uh,
you. In this video,
yes,
we
sir.
will demonstrate EIC internal project, which is Intrinsically Safe Industrial Gateway, ISIG. This product is designed to meet intrinsically safe standards and provides IoT connectivity in hazardous locations. Front door provide easy access and maintenance to all the electronics inside the ISIG. There are three main boards inside ISIG. These are barrier, carrier, and the interface board. ISIG is now powered on through 230 volt AC main supply. As you can see, all the LEDs are started and few LEDs are blinking, showing IoT connectivity and data transfer to cloud. This is a system on module SOM board using the IMEX93 processors. The SOM board is the core board in ISIG, providing connectivity such as Wi-Fi and BLE, ensuring seamless integration of ISIG in diverse environments. This is a carrier board of ISIG, which provide interfaces such as USB, Ethernet, ZigBee, NB-IoT, and the latest two-wire Ethernet APL interface. Carrier board also provide interface to other peripherals as required by ISIG. This is the interface board of ISIG, which provide interfaces such as digital inputs, digital outputs, and isolated RS485. The intrinsically safe design allows this channel to be connected to sensors placed in Zone 1 areas of hazardous locations. As shown in the test setup, ISIG is connected to various peripherals such as ZigBee client, Bluetooth, Wi-Fi, external sensor for temperature and humidity on RS485 bus, industrial Ethernet, digital IO simulator, and Ethernet APL connected on a two-wire APL interface. ISIG device is connected to the Azure cloud and the Azure application as seen on the screen. ISIG board temperature data, external sensor, temperature, and humidity data are displayed in a line chart format on Azure cloud screen. All the four digital inputs and digital output status is displayed in block format. Network connectivity such as Wi-Fi, Bluetooth, Ethernet IP is also displayed here. ISIG IP is developed as a part of a capability building project to showcase EIC capability to develop intrinsically safe products. Thank you all for watching the video.
So I think I missed few things, but if you see this gateway architecture, you will get an idea. When we talk gateway, it should have multiple capabilities, or it should provide multiple connectivity, which I missed many things, but it covers that. So so I'm going back to my point where if you have to create any platform, say suppose if you want to create a very simple agricultural uh, IoT solution for say greenhouse or for what I would say, you might have seen, right? There are various house created within say 1,000, 5,000 yards, and then we do the farming inside that one, and it is fully covered. Sunlight can go very mild, but the exotic fruits, vegetable grown inside. So that kind of stuff can be done with very few things. You need the sensor for soil, you need the temperature sensor, humidity, these three sensors, and then if uh, in a way to increase or decrease the temperature if required, or increase the heat. So solenoid and all that. So there are 5, 6 sensors required. Now you connect that uh, uh, with your gateway, uh, and you monitor the data, you increase the temperature or whatever required. So accordingly, you can do that one. So point I'm saying is making IoT solution, taking off the shelf component much easier. But if you have to build customize, say suppose I don't need so many, I need only one Bluetooth, one digital, something like that, then I should create my own hardware for a gateway. So which will be cost effective if I am making in thousands or 10,000s or in lakh, then only it will be easy. Otherwise, it is better to use the 1,000, 2,000 rupee Raspberry Pi. So same way, cloud platform, what you saw this, we have demonstrated for this intrinsic, but that can be tweaked or used for the medical. Uh, we have a one more use case where we use all the charger data to be stored at the cloud and visualize. For that also the same platform has been used, but the UI will be slightly different. Hope that gives some idea what are the components, and if we have to develop something like that, where to look for various resources. Yeah, so that is all from my side. I think we are early. If we have more questions, we can talk. Uh, I like in my introduction, or sorry, while introducing me, Madam has said, so I am with eInfochip past 10 years. In that I have developed two IoT platform, one for medical, one for industrial. Currently, we are designing that AC/DC charger, so that also we take it to the cloud. But here more focusing on the completely designing the hardware, so that takes almost 6 to 8 months. We design the hardware which does the DC to DC conversion and then communicating with the vehicle and all that. So I have not touched upon one more important point, which is standards. So we talked MQTT or COAP, that is a communication, but there are various standards applicable in the various stages. Like say, if we talk about say communicating over a Bluetooth device, then we have to follow that Bluetooth standard, which everybody knows. If we have to talk with electric vehicle, then there is a ISO 15118. Uh, Again, they have developed a protocol called OCPP to communicate with the cloud from the charger. Not charger, it's yeah, charger. So that way there are lot of protocol, regulatory, very important part. The which area this device, this platform, or mainly this device will be used in which area, which region. So accordingly, we should follow the regulatory standard as well, applicable for that region. So which we have not touched upon this session. So what I try to cover is what is IoT, uh, data analytics, and the edge computing, and slightly what would be the architecture of that, but not further more detail because that's will take some more time also to explain. Because like as I said, designing just a gateway, we took 6 to 8 months. So if we go in that detail, it's not possible in 60 to 90 minutes. But yeah, I'm open for the question if I can answer. Otherwise, I will share the detail to Jignesh sir, and then he can share with you all.
Excuse me, sir. One question is there.
Please.
Sir, regarding energy optimization in Internet of Things, IoT. So, what are the various possibilities we can optimize the energy in this case through the softwares? Is it possible? What are the various possibilities?
Little bit. Software will be little bit. Like say, if I talk, we worked on the water meter. Okay. So now water meter or even say energy meter installed in everybody's house, right? So that device, if that is IoT enabled, then it should work and it should work on the very minimal battery, right? Or even everybody has the smart watch. So that also one time you charge it will remains for 48 hours, sometime one week. So all that it is possible majorly on the hardware side, and very little bit like say when we are communicating, this Wi-Fi, Bluetooth consumes more power. So they optimize or reduce the frequency instead of talking every second or whatever. So it's need basis. Yeah, if you are playing if you are talking and you are wearing Bluetooth watch and talking over that, so it will continuously sending the data. That is different. But if no, in ideal state, it should go as low as reduce the power consumption. So that is possible, and it is yes. There are various like various stage, various analysis, and that software needs to be developed according to that. But I just gave you example, but it depends on the what device and what is that the function of that device. Based on that we have to do. Now say if I have a requirement of a continuous handshaking, so still every second, instead of second I will reduce to 30 second, I send the handshaking message. Depends, it's what is that needed and what should be the most optimal. But yes, it is possible through software as well, certain level.
Any other questions? Yes, Puneet sir has a question. He has raised his hand.
Please, Punitji.
Hello, am I
Yes.
audible?
Yes, Punitji.
Sir, I want to ask related to security. Do edge computing devices have some kind of security solution for IoT?
So, yeah, so when we talk about security, it's like it starts when I start hardware design of gateway, I should have a security. Now, when I start developing the application or transferring the data, so I should make sure that it is secure. So that's why instead of HTTP, people will use HTTPS, and QTT and COP is a kind of close. So still there is a security built in each layer. uh, uh, yes, it has to be there. And I give a few examples. So if we talk about cloud, then again, there is a different way they it needs to be made secure. So hardware at a hardware level also, nowadays chip designer or the yeah, many of the controller or processor designer, they have a inbuilt I would say TPM I'm forgetting, but yeah, they do have a certain provision where certain area of memory only written once. You write down the certain keys, and if somebody wants to access that, they directly will not get
Hello.
that key, and then it can be made secure. Somebody else is asking. Hope I have answered your question, Puneetji.
Yes, sir.
Yes, any question?
Hello.
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 Yes.
Sir, further I
Yes,
want to
sir.
ask a
You can go ahead.
little bit about further one question I need to ask. Say there are many types of attacks like botnet attacks are there, DDoS attacks are there. So how to encounter how to defend that particular thing at the age level?
Mm,
Is
Can
it
you
possible?
elaborate? No, no. Can you elaborate? Attack means what kind
See
of? I'm
the
not aware. So
say different IoT devices are there and they are maybe vulnerable some kind of say by default configuration and all this. If you heard about the Mirai attack, right? Mirai based attack.
yeah. So again, uh, that is you are right. I'd like say we were working for like say a company. They manufacture the switches and routers. And the switches routers they use the uh, some variant of a Linux operating system, which is they have customized or they have rewritten, I would say. But yeah, still that is there. The base is say Red Hat or Fedora, any of the Linux, but that base is that. But they've used that. And now if there is a vulnerability in the operating system or any of that application, mainly operating system, and then they will release the update. So that needs to be done. So if like say uh, I have designed the product today, gateway or say cloud application or whichever. Let's talk about gateway in this scenario, and I have used the Yocto Linux. And somebody find out that there is a vulnerability and he attacked and he is successful. And before that, if Yocto community or Yocto distribution, they don't release that patch, we will not know. Or if they find out, then they will release a patch definitely. But that's why we see continuously update keep coming to our as simple as Android device or OS distributor also keeps sending the updates. Windows itself keeps sending the updates every week, or whenever there is an vulnerability they find or they find uh, any fix for the vulnerability. So they will not keep the vulnerability open. They will quickly give that fix, and they have to declare this product has this vulnerability, so people can be uh, vigilant and then they can avoid any incident. But yeah, so that is like I design like I have used the kernel, so latest version, whatever. But there is a vulnerability, it is fixed in the next version. If I have not upgraded, then my device is vulnerable. So that is always be there. And that's where there is an entire team keep working for the big company to fix only vulnerability, starting from cloud to hardware.
Okay, sir. Thank you.
Yeah.
Participants, do you have any other questions?
We have to 14
You may
minutes
raise
still
your
left.
hands. Hmm.
I'm stopping my sharing.
Okay, sir. Thank you so much, sir, for your insightful session.
Thank you and welcome.
Mhm.
Sir, thank you as per our need on edge computing and all. But you have
No,
explained
what I said is
yes.
very minimal, but yeah, it is a vast topic in itself. as I said, only designing gateway we spent 6 to 8 months, around 10 to 12 members. So it's that way. Each component is used, and then you need a team for each component, be it a device, be it a cloud, or be it a visual. And third is AIML, which is covered some other topic that itself is a different area. They don't talk anything else. We have the data, we do analysis or AI on that one. So that is another one.
Okay, fine, ma'am. So we'll take a one screenshot with an expert of all the participant who can switch on their camera.
Okay. I request all the participants to please turn on their cameras for few seconds.
Okay, ma'am. Thank you. It's taken.
Okay. Thank you so much.
Thank you.
Thank you so much, sir, for your session.
Thank you.
Joshi, sir.
Yes. Yeah. So
Hmm.
once just within some 5 minutes, Mr. Shalin sir is logged in, and then we'll start. We'll start immediately itself. Shalin sir is actually waiting. Thank you very much, sir.
Thank
You can
you.
log out.
Thank you.
Thank you, sir.
Thank you.
Now you may turn off your cameras. Thank you so much, all participants.
Yes, please. All yes.
All participants can switch off their cameras.
Ma'am,
Yes, sir.
ma'am, you can also switch off your camera. I will just tell you,
Okay.
then you can start. Fine.
Okay, sir.